Hello friends, welcome back in refrigeration and air conditioning subject. Today we are going to learn different methods of duct design. My name is Mr. S. B. Kumar, Assistant Professor, Sharad Institute of Technology, College of Engineering, Yadra, Ichalkaranji. So these are the contents of today's video lecture that we had already studied, that is function of duct, classification of duct, economic factors influence duct layout, duct design methods, dynamic losses and its determination, requirement of air distribution system. So we will start with function of duct. We had already studied air distribution system. So in air distribution system, the duct plays very important role. The function of duct is to transmit air from air handling apparatus to space to be air conditioned. Second most important function of duct is to fulfill this above requirement, above function. The system must be designed within the prescribed limit of available space, friction loss, velocity, sound level and heat losses. Duct systems are also used to bring cooled air to the proper distribution points where several rooms are to be conditioned. This is especially applicable in hotels, theaters, auditoriums, etc. In case of hospitals, theater, generally we prefer central air conditioning system where air is conditioned at a particular point and that air has to be distributed to each and every room separately. For that purpose, duct system is required, and this duct system should have proper distribution points where the several rooms to be conditioned. It is applicable in theater also. Classification of duct. Ducts are classified on many criteria, out of which first one is according to the velocity of air. Depending upon the velocity of air, ducts are classified as low velocity duct, high velocity duct. According to pressure, ducts are classified as low pressure duct, medium pressure duct, high pressure duct. According to supply of air, ducts are classified as supply air duct, return air duct and fresh air duct. Supply air duct carries cooled air, that is conditioned air, to the surface or the workplace where the room is to be conditioned. Return air carries the air from that workspace and it removes that air, it returns that air. And fresh air, whenever fresh air is required, fresh air duct just adds fresh air from the atmosphere through air filter. So economic factor influencing duct layout. Heat gain or loss from the duct. The heat gain or loss in the supply and return duct is considerable because sometimes your conditioned air has to flow from lower floor to up to 30 or 40th floor. In that case, heat gain or loss in supply as well as in return duct is considerable. This occurs due to the duct passing through the unconditioned space. As I mentioned, if we have to condition a room which is at 30th floor and if conditioned air is at ground floor, that air has to travel through unconditioned part. The allowance must be made for duct and heat loss gain in load. Aspect ratio of duct. Aspect ratio is defined as the ratio of longer side of rectangular duct to shorter side of rectangular duct. If A is the longer side of duct, which is shown in the figure by a color, and B is shorter side of rectangular duct, so mathematically aspect ratio is equal to A divided by B. This aspect ratio is an important factor to be considered in the initial design of duct. So in earlier video lecture I had shown some aspect ratio for different applications. Duct friction. This point we had already studied. Any fluid flows through any pipe, then because of friction between that fluid and pipe material, some frictional losses occurs. We call it as major losses. So if a duct friction rate is higher, higher will be the size and aspect ratio. This will be increase the initial and running cost. Type of fitting. The type of fittings can be divided into class A and class B. It is desirable to use fitting of class A, as the fabrication cost of class A is it's a 1 upon 2.5 that of class B. Duct design methods. Now this is the today's video lecture important point, that is duct design method. There are three main methods which are considered for duct design. First, velocity reduction method. Second, equal friction loss method. And third, static regain method. We will see each method one by one. So velocity reduction method. In the velocity reduction method, the duct design in such a way that the velocity decreases as flow proceeds. Again, I would like to mention the same example. If the conditioned air is available at ground level, and if we have to supply that conditioned air to a room which is situated in 30th floor, so in that case, when that air flows, its velocity decreases, and as it reaches to 30th floor, its velocity decreases. So this concept is used in duct design. The pressure drops are calculated for these velocities for respective branches and main duct. If in this example, if we have to carry conditioned air from ground surface, ground floor to 30th floor, sometimes it may have branches. Okay, in every floor that duct have some branches. So the pressure drops are calculated for this velocity for respective branches and main duct. The duct size are determined for assumed velocities and known quantities of air to be supplied through the respective duct. Here we must know the quantity of air which is flowing through duct, and the duct size can be calculated by assuming velocities in by the formula Q is equal to A1 V1. So once Q is known to us, V is assumed, then its area can be designed, right? So A can be designed on the basis of Q and velocity V. Second method is equal friction loss method. In equal friction loss method, the frictional pressure drop per unit length of duct is maintained constant throughout the duct system. For example, if the duct is made up of aluminum material or any material, then the frictional pressure drop per unit length of duct is maintained constant throughout the duct system. The procedure is to be select a suitable velocity in the main duct from the sound level consideration. Knowing the air flow rate and velocity in the main duct, the size and friction losses are determined from the friction chart. Also, we can use Darcy-Weisbach as well as Chase's equation as Darcy-Weisbach equation HF is equal to 4FL V square upon 2GD, where F is the coefficient of friction, L is the length of duct, V is the velocity of air which is flowing inside duct, and D is its equivalent diameter. Third important method is static regain method. For the perfect balancing of air duct layout, the pressure at all outlet must be made same. This is the principle of static regain method. This can be done by equalizing the pressure losses in various branches, and this is possible if the friction loss in each run is made equal to the pressure gain due to the reduction in velocity. Main advantage of this one is it is possible to design long run as well as short run for complete regain. It is sufficient to design main duct. Dynamic losses in duct. First one, pressure losses due to enlargement. Second, pressure losses due to contraction. Third, pressure losses at inlet and outlet of duct. So this is the pressure. This figure indicates pressure loss due to enlargement. If we have to carry conditioned air from smaller diameter to larger diameter, as the diameter changes abruptly, then pressure losses in this duct where there is a sudden enlargement can be given as pressure loss is equal to 1 minus A1 upon A2 bracket square into V1 upon 4.04 bracket square, where A1 is the cross sectional area of duct at section 1,1, A2 is the cross sectional area of section 2,2, V1 is the velocity of air at section 1,1, and C1 is 1 minus A1 upon A2 bracket square, which is known as enlargement coefficient. So the previous formula can be rewritten as pressure loss is equal to CR into C1 into V1 upon 4.04 bracket square, which is nothing but CR is equal to C2 into V2 upon 4.04 bracket square. Pressure loss due to contraction. If the diameter suddenly decreases, then such loss occurs, and pressure loss due to sudden contraction is given as pressure loss is equal to 1 minus A1 upon A2 bracket square into V1 upon 4.04 bracket square. This formula can be modified as C1 into V1 upon 4.04 bracket square, which is equal to C2 into V2 upon 4.04 bracket square. So requirements of air distribution system. There should be enough entertainment of room air with the supply air, so that upon reaching the occupied zone, the air stream attains desired temperature. As soon as conditioned air is supplied to unconditioned space, the air stream must attain the desired temperature. That is the first requirement. Second requirement is that the temperature throughout the occupied zone of the room should be within plus minus 1 degree centigrade of the design temperature. Third, only minor horizontal or vertical temperature variation should be there in occupied zone. Fourth one, noise level should be below objectionable level. Fifth, effect of natural convection and radiation within the room should be negligible. The terms used in air distribution: first, outlet, it is an opening which air is supplied to the conditioned space. Intake, it is an opening through which air is returned from space. Grill, grills provide decorative covering for outlet or inlet. Diffuser, diffuser is an outlet grill designed to guide the direction of air. Register, it is a grill provided with damper or control valve. Drop, it is a vertical distance that the lower edge of horizontally projected area stream drops between outlet and end of its pipe. Types of air outlet. The picture shows grill outlet, core width, duct width is shown, frame is also shown, and duct length is also shown. These outlets have adjustable bar grills, which are most commonly typed with vertical and horizontal vane. Slot diffuser It is an elongated outlet with an aspect ratio of 25:1 and the maximum height of 7.5 centimeter. They are used in side walls but a higher height of the floor. Ceiling outlet. They are mounted in the ceiling. Multi-pass, round, square or rectangular outlets are preferred. Perforated ceiling. In this case, confined space above the ceiling is used as supply plenum. The air from the plenum is supplied to the room through small holes or slot. The air is supplied at the rate of 0.3 to 4.5 meter cube per meter square of the floor area. They are specially suited for large zone. Thank you very much.